Hello, everyone. Thank you for joining us today in this new Madrid-GUG meetup. It's my pleasure to have here Paul King. I will just introduce the group and then I will leave it to him. So it's been a while since we have our last meetup, and we are back with the new features and everything related to the Groovy 4 release. So you already probably know us. We are Madrid-GUG. You have all the information in our webpage, madrid-gug.com. We have a lot of videos for the last 8 or 9 years. So if you want to talk here, just ping me or ping us in our Twitter account. Just very quickly, we have an open collective. So if you want to contribute to the group, you can do it. We use the money basically for the certificates, the domain, and probably a few more things that I don't remember now. We are going to raffle today. We have one of our sponsors. The group helps CodeMotion Madrid to review the talks and collaborate with them. So we will raffle a few tickets to the online conference. As you see there, it will be from May 10th to 12th, online conference again. You have all the information in that URL, and after the talk, we will raffle a few tickets. And if you want to join the raffle, that's it. You basically need to sign up in this URL, in this QR code. Just put your name. That's it. So I know you are interested in the raffle. We will also raffle a JetBrains license at the end. So if you are interested, please don't leave after Paul finishes. And I think that's it. Let me try to, if I know how, stop sharing my screen. And that's it. It's all yours, Paul.
Hello, everyone. Hopefully you can all hear me. So I've got a talk about Groovy 4. So Groovy's been progressing very well, and we're on to Groovy 5. We're still in early days of planning for that, but there's some exciting things that we'd like to put in it, and we're going to get a whole bunch of feedback from whoever we can as we move along that path. But the good news is that Groovy 4 has been out now for a few months. It's starting to get used. We've ironed out a few little wrinkles and bugs in it when it first came out, and things are going well. So most of you who are here will know what Groovy is, so I don't really need to go into the details. It's a language that should be familiar to you if you're a Java developer, but it's got some nice extensions and it's very extensible. And we'll see some of the extensions coming in for. The code base, it's all progressing along nicely. We've got 500 contributors, over 1 billion downloads. Late last year was the download figure got to, which is sort of a nice milestone to have. So it's still very popular. It's still, the downloads are still increasing year by year. So it's nice to see that happening, and still plenty of people interested in Groovy. So come along to the project if you're interested. Okay, so before moving into Groovy 4, just sort of setting the scene, the Groovy 3 that came out about a year before Groovy 4 was released. And it was quite a while in the making, and it introduced a brand new parrot parser. That's the thing that enabled us to support lambdas and method references, do a whole bunch of additional Java compatibility with all the latest versions of Java, but also add a whole bunch of new operators, so new operators and new features that are specific to Groovy as well. So that's sort of set the scene. It was also where we started doing the initial work to support the sort of modularization of Groovy. Well, not the initial work, but some big steps forward in terms of complying to the split packaging requirements for Groovy and so forth. Groovy 4 takes us some steps further in those directions, and we'll get to that as we go. So here's the summary of the things that have happened in Groovy 4. There's a bunch of consolidation and structuring. So I'll talk very briefly about that. It's probably boring to many of you. It doesn't impact your lives too much, but it was important for us, and it makes Groovy a much better project to maintain and evolve going forward. So there's some key things that I'll talk about those briefly. Then we'll look at some language features, so records and switch expressions and so forth. A little bit in the libraries and tooling, I'll go through that fairly quickly, and a little bit more on AST transforms, some of the changes in that space. Now, this whole slide deck will be available. I'll tweet out the where it is. All of the examples will be on GitHub. So most of them are already there in an upcoming Groovy GitHub site, but I'll send out the links to all of that. So don't be trying to copy all the code or anything like that. Everything will be available and you can try it out yourself at a later date. So let's look at the first part of this. So again, sorry if it's a little bit boring and you want to look at all the nice shiny new features, but just to sort of, some of these will be big gotchas if you don't understand what's happened. So it's good to know about what's happening. So first of all, the Maven coordinates changed. So don't go looking in org codehouse Groovy. If you go looking for Groovy 4 over there, it'll look fairly empty and you'll think, oh, it hasn't come out yet, but it's all under org Apache Groovy. We've been in Apache for several years now, and it's good to actually have the Maven coordinates converted over. Now, just because we've converted the Maven coordinates over, that doesn't mean we went and changed all of the package names for all internal classes. So if there was an org codehouse Groovy package name for some internal class, it's probably the same. Over time, we've just been slowly converting them over when we create new classes or do refactorings or whatever. But we don't go and change those things when we don't need to. And so you'll still find some of the old org codehouse Groovy package names around. That's not a worry. Just keep using things as you need to use them, and you'll find where everything is. Now, some of the modules have changed as well. So Groovy's packaged up into a bunch of sort of modular jars that previously have just been jars of useful functionality, but they're getting closer and closer to being full-blown Java-like modules. And we'll see what's been done to make that happen. In Groovy 4, we removed 2 of these modules that aren't being used. So there's a Bean scripting framework, which is a project that's not actively maintained anymore, and most people use the built-in Java scripting capabilities, JSR 3.2.2 or whatever it's called, and Groovy supports that well, and that's what we're supporting moving forward. You can go and use the Groovy BSF out of Groovy 3 if you really wanted to, and for the moment that still works happily. Jaxby, we only had some very, very minor enhancements we made to Jaxby. We don't think they're worth having a whole separate module just for those. And there's the way Groovy's, the Java JDK has evolved. It's actually a painful thing to maintain that. So that's disappeared. Again, if you really need it, you can go get the stuff out of Groovy 3 and still use it, and it'll probably all work fine. There is 5 new optional modules. So there's one to do with contracts, Groovy queries, macro libraries, TOML, and type checkers. And we're going to go through and see all of those, so I won't spend any more time on that. The only other thing changed was if you go and use Groovy All, it's a sort of a POM that goes and downloads the most common Groovy modules. It used to get Groovy test ng, it doesn't anymore. It didn't used to get Groovy YAML, it now does get that. And that's basically, we made that change based on we went and looked at the download figures, and Groovy YAML is like 10 times in more use than Groovy test ng, and it just seemed to make sense to do that. So if you don't want to have that change, go and just download the individual things in Groovy All yourself, or go and get your Groovy test ng or whatever it is you might want separately. Now, there was a little bit of rework we did in Groovy 3. So if you've ever gone and used Groovy's XML parser, you never needed an import for that previously. So it was in the Groovy util package, but that won't fly for all the different modules, having Groovy util represented in multiple places across those modules. So in Groovy 3, we provided 2 versions, one in the new home in the Groovy XML package, which is resides in the XML, in the Groovy XML module. And that's the one you should be using going forward. In Groovy 3 time span, you can use either one, but from Groovy 4, you have to go and use the new one now. And that makes all of the jars fully compliant in terms of the split packaging requirement. So that's great. So go and look at the release notes if you've not gone and done a little bit of work to go and tidy up your imports related to those. There's some in Groovy XML, some in Groovy Ant, some in Groovy Swing, some in Groovy Test. More details in the release notes for Groovy 3. Groovy 4 just took the next step, and as we promised we would, we got rid of the old names. Okay, so I mentioned that Groovy 3 had this brand new parrot parser. It was based on Antler 4. The initial plan was that we were just going to have a new parser, and that was all going to happen in Groovy 3 timeframes. But we decided in Groovy 3 would actually have the old parser still sitting there. And then if anyone ran into any problems when they were using the new parser, they could just flip back to the old parser. Well, we haven't had any feedback saying that people are having any problems with the new parser. We know the new parser is a little bit slow, and we're doing some more work to speed that up. But certainly in terms of parsing Groovy programs, it's doing everything that people need. So the old Antler 2 based parser is gone, and we're going to now focus our attention on the Antler 4 parser, and we're going to spend some more time getting that more efficient. Also, again, this is a sort of an historical thing. Way back, must be nearly 10 years ago, the invoke dynamic bytecodes were introduced in the JDK. And we started using those in Groovy. They promised to be the things that dynamic languages like Groovy would particularly find useful. And to some degree, that was the case. What we did find in the early stages of when they invoked dynamic bytecodes were introduced, they were a little bit buggy. So again, rather than just doing a switch over, which was the initial plan, we were told this was going to be a great thing, we should just jump straight over. It didn't turn out to be the case that we could do that nicely. So we supported both and let you switch between the two. That was many, many years ago, and that the invoked dynamic bytecode now is rock solid, and it's pretty fast. And we've done a bit of work we had highly optimized the classic bytecode. We've done a bit of work to make the indie bytecode be a bit more optimized, and now we're going to focus on doing that more in the future. So we'll spend more time getting the indie code really nice and efficient. So that's nice and clean now. We've removed a lot of old stuff that we were, whenever there was a bug, we had to go and work out, is this a bug just in one half of these two options? Is it in both halves? Do we have to fix both? Do we have to have a test to cover both cases? And there was quite a bit of a maintenance overhead there. So now that that's all cleaned up, it actually allows us to move forward more quickly and cleanly. So that's great. Okay, so that was just a bit of some of the behind the scenes stuff that happened, the Maven coordinates and some of the other internal workings changes. So probably what you're interested in is the sort of shiny features. Now, some of these shiny features are actually shiny features in the Java land that we've brought support across. But as we frequently do in the Groovy space, we make things nicer as well. And I'll explain some of that as we go. So we've had switch statements in Groovy, as does Java. The Groovy switch statements are quite a more flexible beast than what's been in Java. But switch expressions are sort of moving in a different direction, and they allow a result to come back from one of these, a switch expression. So in the past, if you wanted to, for this bit of code here, it would be a statement. So it would be, you'd have to either put it inside a method and return something, or you'd have to set some result value, and you might have some breaks and other things in there, and the code would be quite verbose. If what you're actually trying to do is just get some value returned from a whole bunch of different case branches. So now with the switch expression, that can all be done in a nice compact form. And we support the various flavors that you'd expect to see in Java land. Okay, we do that for Groovy. We've also brought across Groovy's enhancements, so we'll see some of that as we go. So that's what one looks like here. So for this one here, we've just got we're feeding in an integer 9, and then We've got a couple of different case branches there. If it's 6 or 8, we'll turn B, which won't be the case for this example. If it's case 9, we'll return C, and that's what we're going to return because that's what we're feeding in. And we can do an assertion to check that that's the case. Okay, so Groovy's had a more powerful set of the case expressions themselves. Sort of what you'd think of as a case label, or you'd have a selector constant in Java land. So in Groovy land, you can have a range. So I can have Monday ... Friday. I can have lists. I can have a regular expression if it happens to be a string that I'm is the thing that I'm switching across. I can have a full-blown closure. I'll show you that in the next example. So all of that added functionality that Groovy brings to the table all comes across in switch expressions as well. So here we can say that the weekend is going to be Sunday or Saturday, and the weekday will be the Monday or Friday, Monday to Friday, and a little bit of assertion there to check that out. And there is a yield version as well. And that's shown here. So the previous slide has the arrow that you'd see in Lambda expressions. And you'd normally have a return value or a block appearing on the right-hand side. If you do the colon as per the traditional case statement, that's supported as well. You can have multiple statements there, but you need a yield. And the yield is the thing that's going to return the value. Okay, and here we're showing that we can use a full-blown closure in the case selector there. Okay, so here we're going to say if the toString of the enum, so the Sunday, if you do the toString on that, it'll be Sunday or Saturday. If the first character happens to be an S, we'll say that that's the weekend. Just another example. So all of the, and I could use regexes and so on and so forth. So all that's there. Okay, so how does that? What's the summary of how this differs from Java? Well, the Groovy one works all the way back to JDK 8. It supports the different flavors, the yield syntax, or the lambda-looking switch rule expressions, as they're called. The Groovy one supports the extra functions. You can have null as the case constant. You can have a closure, a range, and a class expression, and so on. So they're all available, and they're all available from JDK 8. So you can, if you want to have more advanced switches, including that nice compact syntax, that's all now available there. And the enhanced switch material, it's in preview in 17 and 18. There's another preview coming, I believe, in 19, and it supports type patterns as a constant. And they were previously called a guarded expression using a double ampersand. So it's the logical and. It's now using a when clause in the latest preview. And the ability to have null as a constant, all of that's coming in, so it'll still be in preview in 19. So I guess it'll be fully available in a future version. You can go and use class or closure expressions, or you can still use null directly now. So you can get all of those in JDK 8, and so all of that's there as well. So it's a pretty good story there for Groovy in that space. Okay, so Groovy's provided over time a whole bunch of mechanisms for removing boilerplate, including AST transforms, things like add immutable, and we'll come back and see how that all ties in a little bit. Java's introduced records, and it's Java's currently supported mechanism for drastically reducing boilerplate for data classes. So I can have a record point, and I can have perhaps an X and Y coordinate and a color perhaps, and then I can declare that all as a one-liner, and the sort of tuple-looking expressions become the fields in the record, and it's a shallow immutable sort of data structure. So it's for storing data. I can put methods inside there as well. and do a small number of things inside, but it's not designed for rich classes. It's designed for data classes. And it's got a bunch of features that support that context. So implicitly final, private, final fields, etc. You can go and look up the Java docs and you'll see that the Groovy, what Groovy's doing matches what Java does there. So if I'm trying to create a point that represents a point at the origin with some color blue, then I can declare one of those. Now, Groovy lets you do that using an annotation if you want. So it supports two different syntaxes. I'll explain when you might want to use either one. And I'll explain the significance of that. So you can go use record type and do it the class in slightly longhand version as in the top of this slide here. And that'll achieve the same thing as if you use the record syntax. Now, Groovy gives you a few little bells and whistles, and these bells and whistles you can turn on and off. So if you want to make a record that's exactly like a Java record and no more, no less, you can do that. There's some options you can go and switch off. But by default, you'll get a few little bells and whistles. So you can treat a record as a list. If you call .toList, it'll go get all the record values and return that to you. You can use the normal indexing operations. You can get the size, all the things you would expect to be able to do with a list-like structure in Groovy. You can go and use all of those. You can treat a record as a map. So the record components, the component names become the keys to the map, and the component values become the values in the map. And so you can treat it like a map if you want to. You can turn on, so up the top line, I've put a record options annotation onto the record. And you do the same thing as if you're using record type, you'd have record options and record type up there. And in this case here, I've turned copy with on and components on. And this is also where I could go and turn off the toList, the toMap, all of those features if I didn't want those. By default, they're turned on. But if you, again, what I'm saying is if you want something that's no more than what the Java one gives you, you can go turn those off with the same options capability. So with copy with turned on, I can take my, here I've got different materials. I've got straw, sticks, and bricks. And I can take my sticks and do a copy with and just change some of the components in that record. If I ask for the components back, I get a tuple, a typed tuple. So if I'm using static typing or type checked code, I'll get back things that are, in this case, strings and ints and so on. And then I could automatically do dot uppercase or whatever I might want to do on a string. And that'll be, I can have all that automatically type checked and so on. So all the things that would make records useful, but still in a form where I can treat them as a sort of a list of components or a list of types, or so the tuple type basically is a useful feature to have. Now, something else that is supported is, so by default, if you start using records, record options works with pure records or record type classes with the record type. So you can see in this example here, record options in the last example is used with record type, but in the first two examples is used on records using the keyword syntax. Now, regardless of which syntax you use, that's not what determines whether you get a native record or what we refer to as a record-like class. So what we do for records, we've supported record-like classes with immutable and canonical for a long period of time. And when you're on JDK 8, we give you a version of similar to previously immutable ones, but with all the properties. So all the names of the getters, no setters, the shallow copying, like what records give you. You get all exact same code that you'd get in a Java record. You can get that on JDK 8, but it won't have, it won't be listed as a record in the bytecode. So we call that a record like, or an emulated record. And you can do that on JDK 8. Now, by default, if you're on 16 and above, you'll get a native record. And if you're on anything below 16, you'll get an emulated record. But you can go and force native. And then if you go and try to compile that on an earlier JDK, it won't compile. You'll get a compilation error. Or if you're on, maybe you're on JDK 17, but you don't really need the native records, you can force it to be emulated as well. So you can choose in between those. Okay, so just sort of summarizing if you're using Java, if you want the low boilerplate option, you can use records, and that'll be for 16 and above. A couple of versions earlier if you switch on preview. In Groovy, you can do the same thing. So if you want native records, 16 and above, you'll get that. If you want emulated records, you can get that all the way from JDK 8, but it's actually just going to have that record type annotation on it. So Java won't recognize it as a record. Groovy will recognize it as a record. The code that's inside it will be the same as what's in a record, more or less, give or take a little bit to do with serialization. But it'll be essentially like a record for most people's usages. And you've still got all the other options for low boilerplate code if you want something that's not quite a record. So if you want immutable, if you need the deep immutability, so rather than just shallow immutability, the deep immutability, you can go use @immutable, you can use @canonical, toString equals and hash code, all variations thereof to get slightly different ways to get less boilerplate code. Okay, the next thing I want to talk about is sealed. And again, we could spend a lot of time talking about how sort of sealed fits in. My short version of this, I could just give you one slide and say, yeah, all the seal stuff that Java's now got, Groovy's got as well. So that's sort of one answer, but a lot of people don't sort of understand why they would use sealed. And there are some differences in terms of bells and whistles. So I'll spend a little bit of time talking about sealed. Hopefully for those of you who are sort of already familiar with it, it won't be too long-winded. Okay, so we know inheritance is this powerful mechanism for building systems. But so here I've got shapes and I can have squares and circles. And I've got some fairly brute force ways to put some limitations on how things get, how inheritance is carried on in my inheritance hierarchy. So here, shape can be extended by anyone, square can be extended by anyone, but I've got an ability to not let anyone extend circle, and that's by making the class final. So it's even in the early days of Java's inheritance, they kind of knew there would be times when you want to curb the amount of inheritance that's there. But over time, we've kind of realized that actually it's more than just this brute force, all or nothing sort of mechanism. So we've kind of, you would have heard things like favor delegation over inheritance. So what we've found over time is that inheritance is a really great, powerful feature, but in some sense, it works really, really well when you extend the class hierarchy according to the directions in which it was originally designed to be extended in. So there was this idea that we'd get lots and lots of code reuse by doing lots and lots of inheritance, but it turns out not to be the case because it's hard to factor into our class hierarchy the kind of behaviors that happen in this inheritance tree. And you've all heard this, and seal types gives us a way to put more structure around how we do a little bit of control on the inheritance. So it's a controversial topic in that some would argue, oh, we should have made final be the default and have if you really want inheritance, you've got to call a class open or something and turn on inheritance. So we could go and debate that. We're not going to debate that. Groovy lets you do it either way. It's just going to give you the mechanisms to do whichever way you like. Okay, so if you do start using lots of inheritance, you'll find that you need to do lots of defensive programming in parent classes, or do additional compiler checks, or pattern matching gets complicated and so on. And previously we've had these sort of brute force ways. We've had final, we've had package private parent classes, but it doesn't really work too well if you want to have interfaces, if you want to have abstract parent classes. There's limitations on what you can do. So we've had very, very crude mechanisms for limiting inheritance, and Seal just gives us more things in our toolbox for having inheritance hierarchies that grow in a sort of controlled way. There's the concept of seal types, which puts extra controls, and then you've got unsealed types, which allows you to, once you go into a hierarchy where you've said, oh, I've got controls here, if part of that hierarchy doesn't need the controls, you can unseal a part of it. So once you select some part of the hierarchy is going to be sealed, then everything in that hierarchy below there is sort of marked as sealed, and this lets you unmark a certain area. So there's sealed and unsealed as two concepts. And I'll come back a bit later and we'll see when you might do that sort of thing. So I've got a bit of a contrived example here. So I've got some, I'm going to do a sort of mini calculation sort of app, and I'm going to have calculations that multiply numbers together, add numbers together. And I'm going to have different classes that represent the different operations. So that's all well and good. And what I could do is inside my multiply, my add, my divide, my subtract, whatever, I could just write the code for each of those operations, and that would be fine. I've got a abstract method there, calc. I could just go and implement that inside every single one of my new operations, and I'd be done. But I'm kind of feeling a bit lazy. So I know Groovy is very powerful, and it's got a Groovy shell. So what I'm going to do is I'm going to create a abstract class that makes use of the Groovy shell. And in fact, what I'm going to do is I'm going to take my first operand, take my operator, take my second operand, concatenate them all together as a string, and I'm going to treat that as a program, compile it up and run it and execute it. And the result of that program will be what my calculator returns. And I'm thinking, gee, this is great. Now I can get lots of operators here. I've got multiply and add just by putting in the operator as a character there, a bit of a string. And I'm thinking, this is going to be great. I can add, subtract, and divide, and worry about divide by zero errors and other things later on. But I can even think, oh yeah, I could use a double asterisk to get power operator. I can probably get mod, and maybe I can even do binary integer, binary or and binary and operators, all just with single sort of characters here. I might have I'm on a winner, and all's really good. Then someone comes along and they supply an alternative add. And when I go and use this, it looks like it's an add. And in fact, when I run it, it adds the two numbers together. But as a side effect, so my code here isn't purely functional or anything. It's got a side effect here. It's printing out my etc password file, or some other Windows security file if you're on Windows, or whatever your operating system might be, just to stand it out here. So who knows if that's going to be a problem, where that's going to go, and if it's going to be a problem, but I could be writing it anywhere as far as this is concerned. And this isn't sort of guarded in the class hierarchy that I sort of had. And yes, what I could do is harden my program in various ways. Groovy provides various things that would allow me to lock down, in fact, the kinds of programs that I could compile up in this Groovy shell. I could use Groovy policy files, at least for a little while longer, while the JDK supports them. I could do a whole bunch of things, parsing what's inside that op there. And yeah, there's lots of ways I could harden it. But what we can do is just seal that hierarchy and put in my multiply, my add, and then no one else can come along and do a hacked add or anything like that. So I could bring the calc method there, push that up into a interface. And then I could go and allow people to write additional implementations that I might use, but only my multiply and add can use my super duper powerful Groovy shell variant here, which I know is potentially subject to a little bit of hacking and who knows what else. So sealed here is, I've presented this as sort of, it's a bit contrived, presented it as sort of a hacking scenario, but really it's not so much about hacking. It's more usually about whoever wrote so what you're trying to do in these class hierarchies is move code up the hierarchy as far as possible to maximize reuse. But as you're moving things up in this hierarchy, you're making certain assumptions about how the code works. And you often have to make that code a lot harder than you would otherwise have to do if you've got unfettered inheritance in play. So just another example, again, it's probably pretty obvious to many of you. Here I've got a material abstract class and I've brought some functionality up into a toString. I've brought that up the hierarchy so each class doesn't need a toString. And I'm just going to get the class name and print that out with the color. So every material has a color. And now I've got straw, wood, and bricks. And colors yellow, brown, and red, and everything's all fine and dandy. Now I'm going to add a new class here. It's class glass, and that's sort of transparent. So I won't put a color. I'll put null as my color here. And what's going to happen here? Well, I'm going to get a null pointer exception. And we all know that you shouldn't be throwing exceptions in glass houses, so not surprising. But the moral of the story here is that classes added later may yield unexpected results. And yes, using null here is probably a bit of a code smell. And yes, I can go harden this up. I could go color question mark dot to lowercase. I could do some sort of non-null annotation, perhaps when I'm setting up my material with that color field. Lots of options where I could harden this. But again, the idea here is you'd lock it all down, seal it all down. And then if you've got some glass extension that you want to add, you've got to come back in here and do a assessment of, can I add it in? What might be impacted? And then you can just add one more class, the glass class, into your permits clause once you've assessed what's going to happen in all the different possible cases. So in this case here, I would assess what I'm going to do in that particular case. Maybe I have an invisible color or something instead of the null, or whatever it's going to be. I'd assess that and work it all out. And at that time, I'd decide if I'm going to permit additional classes here. Now, switch expressions that we saw earlier is a special case here. And so again, it's very much like we saw the example of pulling up the toString, pulling it up to the parent class. Here we've pulled up a warranty method, and straw you can only use in light winds. Bricks can withstand huffing and puffing. So this is sort of warranty, and we've pulled it up to the higher class. Now we could have an argument here about, is this good OO design or not? And probably it isn't in this case. Maybe I should have this warranty field inside each of my classes here. If this was all that was in them, that's probably what I'd do. But we have that tension all the time. Some stuff is going to be wanting to pull up. Other stuff might be pulled into it might be a warranty util or a material util class that might print out warranties for things, and I might keep my materials very clean and have things to do with warranties in a different place. An OO thing would push it all down into all the different classes. So I've got tension there, and that's a debate that's still going to have to go on, but sealed gives me another option for what I'm going to do to sort of lock things down until I've had that debate. So, oops, I went the wrong way. So again, if I add a class glass here and call warranty, there's no glass in my switch expression here. And that might end up doing nothing. I didn't put a default in here. Depending on how you set this up, you might get a null pointer exception, you might get a null, you might get a compilation error if you, depending on if you've got static typing turned on or whatever. So we're not going to go into the details of that, and that's going to be an evolving story. We're adding in more support for picking up some of those things. When you've got static typing turned on, there'll be more checking over time. At the moment, it just returns null in this particular example, but that'll be an evolving story. The thing is that sealed, again, just gives me more options on what I'm going to do. So I lock this down as sealed, and then I won't be able to compile glass as something that extends the material. And I come back and I have to make a conscious decision over, oh, this warranty method should it be like this? Should I add another branch to it, and so on? And you go ahead and do that. Okay, so just fleshing out, that's pretty much all there is to do with sealed, but just to sort of make sure we're all on the same page. You can use the sealed, I've been using sealed keyword here. You can use an annotation or the keyword. You can use it with classes or with traits or with interfaces. And if you've got everything in the one file, and eventually it'll be in the one, if you all compiled at once, you can leave off the permits clause and it'll infer that for you. So it'll go and look at all of the things that extend or implement your interface or your abstract classes, and it'll automatically add them in as the permitted subclasses. Okay, so that's the various flavors of everything. It doesn't matter which of these, whether you use the keyword or the annotation, you get the same thing. So you might use the annotation if you're using an IDE or CodeNarc tools or something that doesn't know about the sealed keyword yet. So you can happily go and use that sealed annotation. You'll still get a native sealed class if you're on JDK 17. Generally, the keyword's preferred. Again, like we saw with records, you can have native or emulated sealed types. So if you're on JDK 8, you can have a sealed class. It'll just be that sealed annotation in the JDK 8 land. It won't be recognized by Java as a sealed class, but Groovy will recognize it as a sealed class. And you just automatically get native sealed classes if you're on JDK 17. But again, you can force it. You can force emulation, or you can force native if that's what you'd really like. And you can go look at the release notes and see some more examples, but sealed types are good for abstract data types. So here I've got a tree with a singleton and a canonical with left and right nodes. So when you're writing these sort of data structures where you've got multiple classes making up the abstract data type, it's often a good thing to have sealed in that sort of scenario there. In general, you might have parts of your hierarchy that you don't want locked down and other parts where you're not so worried. So I might have, like my shell op, it would be insecure if I just left that open. So I seal that down, but anyone who's not going to use shell op and going to implement those methods by hand and do a proper implementation of my calc method, I might let anyone extend some sort of interface. So I might have that side of my hierarchy unsealed, non-sealed, and the one that was from shell op would be locked down, that would be sealed. So generally you can have a mixture of these things. So here I might have a sealed shape. I can have a final class circle. I can have a final, a non-sealed polygon. That lets me have any kind of extension to polygon. So here I've got a pentagon, but the code inside polygon, anything that I bring up to that level in the hierarchy, I better harden that for additional polygons if that's a possibility. Well, that's a possibility. So I better be a little bit careful of the code inside polygon. The code inside shape, I can be a little bit less worried about how robust that is, as long as I know that I'm dealing with all circles, all polygons at this interface level, and all rectangles. Rectangles itself is a sealed hierarchy and just happens to have squares in my example. So they're the kind of things you can have. Groovy doesn't require you to put non-sealed in to open things up. If you leave all keywords out, it'll become non-sealed, but you can certainly put non-sealed in if you like. And we envisage future CodeNarc rules that might, if you prefer that style and you want to do the sort of Java checking, you'll have a rule that would require you to put that in. So we're sort of following Scala's style, where it doesn't need the non-sealed. Okay, the next feature I want to talk about was language integrated query, or it's sometimes called GINQ, or sometimes Groovy query. We've sort of got a few different names that sometimes gets used. And its goal in life is to give you SQL-like query expressions. So if you've heard of language integrated query link in C#, F#, in the .NET world, it's bringing that sort of functionality over to the JDK space. Okay, so at the moment it works with collections, but we're going to work on native, well, full-blown SQL support in maybe Groovy 5. That's what we're aiming for. We'll see. We're still early days in that implementation, so we'll see how we go. And when I say a sort of SQL-like experience dealing with collections, this is the kind of sort of code you can write. And there's various kinds of projections, filtering, joins, aggregations, sorting, grouping, pagination, nesting, and so on. So they're the kind of things. We'll come back and see some examples. I'll explain how it looks. Here, I'm just going to look at the traditional ways I might work with a collection of, so I've got a person record. I'm going to list of those. And I've got some names and ages in that collection of records. And I'm going to find all the ones less than age, with age less than 40, sort them by age, and then I'm going to collect the name and the age of each of those people, and it comes out Linda and Daniel are the other two people that come out from that. So that's just using Groovy's normal MapReduce on collections. It's using iteration logic there for lazy evaluation of iterations. So that's all fine. You can use streams and Lambda expressions, or you can use the Groovy query, gquery. And it's, if you want to use a gquery, you use the GQ syntax, and then you open your curly braces. Anything inside there can be a gquery. Now you can make, Groovy's got this very extensible nature. You can make that GQ disappear, and you can sort of, if you've seen the way Groovy Shell, you can make it automatically add compile static, or you can automatically do a whole bunch of different things, automatically do imports and so on. You can automatically put your GQ around a Groovy Shell, and then you can just type in the stuff that's inside the curly braces there. So here's the exact equivalent to what we saw before from P and people, where p.age is less than 40, order by p.age, select p.name, p.age. And if you go and run that example in Groovy Shell, you'll get nice little toString on the result from that query. Okay. Now you can do this with JSON. So I've got a little bit of JSON code here. I'm using the JSON slurper just to slurp in a bit of JSON code. And I was always told as a kid, eat all your oranges. They got lots of vitamin C. Here we're just going to see if there's any other fruits that we might be able to eat that might give us higher concentrations of vitamin C. Turns out there are some. There's kakadu plums and kiwi fruit give the two highest from the ones in this list here. Well, it's actually per dollar is what I'm also stingy on price. So even some that have got really high concentrations of vitamin C. If they cost too much, I'm not going to go buy them. So I'm going to order by the concentration of vitamin C, but divide by the price of the fruit. Okay. Again, if we had that same information in XML, you could do the same thing in XML. Okay. And we can do joins and order bys and all those things. They work happily. Now, at the moment, this doesn't work, I'll say natively on databases, and I'll explain what I mean by that. But for simple cases, you can go and use Groovy's normal SQL capabilities. You can use data sets or SQL, the SQL.rows or there's rows, various flavors that Groovy provides for doing nice compact SQL interactions. And they return collections of things, and you just go and use the G queries on those collections. Now, we don't regard this as native SQL support, in that the join here isn't pushed back onto the database. So if you've got multiple dimensions that you're going across, I've only got 2 dimensions here, and I only had a handful in each of these, so this would be fine. But if I had large volumes of data in my tables, and I had more than just 2 tables, then I'd obviously want the database to do those sorts of joins. It's super efficient at doing that kind of thing. And I don't want to pull all that data down into memory. I want the efficient database engine to do all that for me. And that's what we don't support yet. And that's what we're going to be working on. So anyone who's interested in wanting to help us do that, if you've seen JOOQ, you'll know the kind of thing that we're heading towards, and but using this syntax rather than the sort of fluent style that JOOQ would give you. What else have we added? There's enhanced type annotations. So Groovy, for quite a few versions now, that you can put annotations in a whole bunch of different places, obviously on classes, methods, parameters, all sorts of things. Now they can go on types as well. So it's just available in more places. So I can have a, here I've got a non-blank string. Whereas previously, I think you could put that annotation in, but Groovy would just throw it away. Whereas now it's going to be happily sitting inside the bytecode as per what Java would do. Okay, so Groovy used to put things in the bytecode if it was on a parameter or on a method or method return class and so on. So lots of places, but now in more places. So here we've got, if you've used the JQuick property test library, which is it's a fantastic library for doing random generations of data, if you like, that lets you test properties. And that's a sort of JUnit 5 compatible sort of library. So you can happily go use it with Spock, or just straight with JUnit 5 in Groovy land. And in this particular case, where it's going to go and run a whole bunch of tests for us, 1,000 tests or whatever it might be, that's configurable. And it's going to generate a bunch of lists of numbers between 0 and 10, and they're all going to be unique. The lists that it's going to generate for us are all going to be of size 5, and then it's going to assert some properties on the random generated data. So if you've used the bean validation framework, again, this non-blank strings, that part wasn't supported before. So the green stuff was all supported previously. The yellow stuff is now additional information that's in the bytecode that these frameworks, JQuick, the bean validation framework, they can all, and a whole bunch of others, can all make use of. So that's all good. What else? Libraries and tooling. We have Groovy's type checker is extensible, so you can enhance it. And we know a bunch of people who are doing that, but not many people are sharing any type checkers that they might be writing. So we thought we'd start the ball rolling and would include one that we've used previously in some places, and it's a regex checker. And we're going to hopefully over time add additional checkers into this, the type checker library that we've got, the library framework. But let's have a look at the regex checker. It's the first cab off the rank. So this is some normal Groovy code. We've got a string that happens to represent a date, and we're going to match that against a regex expression for dates, and it's expecting it in a certain format, expecting 4 digits and then a hyphen or a minus, and then 1 or 2 digits and then a hyphen or a minus, and then another 1 or 2 digits. And I accidentally left off the closing round bracket on my regex expression here. I was just a bit lazy and forgot it. Hopefully I've got some unit tests on this, or if nothing else, at runtime, I'm going to get a runtime exception. It's going to say a pattern syntax exception. Hopefully I've got some unit tests on it, and that it'll pick it up during testing. But if we want to, we can put the regex checker on there, and then this becomes a compilation error. Okay, and so here you put add type check, and you can add a list of extensions. And remember, again, I said you can make Groovy is very extensible. You can make all this. Look, I've added it in sort of longhand here to show the whole thing, but again, you can make all of this, the regex checker part of that go away. You can create a Groovy shell that's automatically got a regex checker added to it, or added to its capability. And then you'll just automatically get these sort of expressions. And when do we get these? You certainly get them when I've got a string and I'm matching it against I'm doing a sort of trying to match a pattern here, but you can use it with the tilde versions. You can, if you're using the Java APIs, pattern.compile, using the match or pattern operators, or the Java API for that, using the regex grouping syntax, either longhand or shorthand. So pattern.compile, p.matcher, m.find, m.group. So all the Java longhands, or all the Groovy shorthands, you'll get those same regex errors at compile time. Okay, so we'll probably add additional type checkers. We've certainly got ideas for doing stuff that'll check for pure code, for pure functions, stuff that'll do null checking without you having to necessarily do not nulls everywhere, or if you do not nulls, it'll do some extra checking for you. We'll be playing around with some of those. Some of those will probably be incubating for a while, and some of them may become built in, who knows. Another area we've got macro support. So if you've ever written an AST transform, macros let you do some of the work involved in that in a much more compact way using Groovy syntax. We know it's people who are using that, but again, not many people are sharing their macro methods they may have written. So we've decided we'll start the ball rolling. We've got some ones here that you might use if you're debugging. So if you're in IntelliJ and you've run some code and it's not working, and you're going to fall back to old style debugging, you might do some sort of print line. And if you've, like me, you might have memorized Sout V, Sout M, a bunch of other things. If it'll give you a system out of a variable, and if you happen to select X, variable X, it'll have system out print line, a string X equals, and then it'll give you plus X. So it's a shorthand for doing a sort of poor man's or an old style debugging print line that'll print out the name of a variable and then its value. Well, we can get the computer to do that for us by using SV. It creates a string that if you give it a list of variables, it'll print out the name of the variable and then its value. And there's a couple of different variations of that. One just does the normal toString, that's the SV. There's SVI that's just calls .inspect instead of .toString, and there's an SVD that calls .dump instead of .toString. So there's those variations. So again, if you're debugging and you want to have something in there, you can do it. There's also a sort of a typed version of that. So if you're actually wanting to do additional processing, you get a named value, and you can go and pull out, tease the different parts. And there's a list version of that as well. So that's sort of some, a little macro that you can use. And again, over time, we anticipate some additional macros getting added there. There's a TOML. So if you've used, we saw XML, bit of JSON, YAML is another sort of format that you might use to store configuration information. TOML is yet another one. So it's an optional module, Groovy TOML, and it's got a TOML Slurper, TOML Builder. You can go and read and write TOML files as well. There's a Java shell. So I've talked about Groovy shell. That was our shell op. And I talked about adding configuration to a Groovy shell that lets you add compile static or add new imports automatically. We're now supporting a Java shell as well, and that lets you go and invoke or compile Java programs or invoke Java programs all inside the Groovy world. So in our test suite, for instance, we go and compile records up as Java records, and then the same code, we go and compile them up as Groovy records. So we go and use the Java shell in our little testing suite, and we compile them up both ways, and we check that we get the same expected results back. So that's how our test suite works. So this Java shell is just a handy thing for snippets of Java code. And so there's a little example that's we're going to enable preview under release 14 of a coordinate record, X and Y coordinate record, and compile that up with Java and create a new instance of that. And we've now got this, even though we've not gone and created a coordinate class at all in Groovy land, we've gone and created one as Java would go and create for us. We've never created a .java file or anything. We've just passed all this in, and it's gone and created that for us and created an instance of us, and we can go and manipulate that now. We've called it toString method. And since we've got that functionality, we put a few little hooks. So if you're on the Groovy console, you can go run as Java or run selection as Java or compile as Java and so on. So we've put the little hooks in for that as well. So if you've got some code and you think, I'm sure this works in Java, you can go and try it out in the Groovy console and then try it out as Groovy and see if you notice any different behavior and see if that's what you expect. We've improved ranges. So there was always an idea of inclusive and exclusive ranges. So now we've enhanced that to be left and right inclusive, and you can be open on both ends if you wish as well. So I want a range of integers between 1 and 5, but not including 1 and 5. Okay, so the yellow is what used to be supported. The green is the new ones. So it's just a slight enhancement to what was already there. Okay, so I talked about AST transforms, mentioning them all over the place. I presume most of you know what they are. They're Groovy's hook that lets people outside, we use it a lot ourselves, but people outside the development team of the Groovy language. So anyone can extend Groovy by using these AST transforms. So they're the hook, if you like, allowing you to participate in the compilation process. And so if I've got a book class, and that would be that Groovy would automatically add getters and setters and do a few little things for us. But if I put toString on it, it'll give me an extra toString method and so on. So this is a way we can participate in the compilation process and say, hey, do a few extra things for me while you're compiling my class. And we can add a few more, and we might get a few hundred lines of generated code. So that's the AST transforms. It's a declarative way of creating classes by putting an annotation there, and that triggers an AST transform that goes and modifies my code and typically adds new things to it. And as you'd expect, we've been adding more versions as we've bumped along. We've got a bunch of new things in Groovy 4. And we've now also got the ability to give priorities. So when you're creating these AST transforms, I said that they're a way you interact with the compilation process. Groovy's compilation process sort of works through a number of phases, and you can have a AST transform that works in particular. You can now have priorities within a phase on the order in which transforms might execute. So that's not something you normally see as a user of Groovy, but if you're writing frameworks, that might be something you might find quite valuable. Okay, so here's the new transforms. Some of these correspond to things we've already talked about. We saw record type, and we saw sealed. There's a non-sealed there. Record base, you know, that might be related to records, you might think, and it is. So they're the new things. There's some more related to a Groovy contracts that I'll talk about in a minute. Okay, so just a reminder of way back in Groovy 2.5, we enhanced these AST transforms by allowing you to have meta annotations, or annotation collectors, they're also known as. So you can do add immutable on a class, and it actually has in an early phase, it splits that into some more fine-grained component annotations, if you like. So add immutable is a annotation collector or a meta annotation, and it turns it into these fine-grained ones. Normally, you don't need to know that that's what's happening underneath the covers. You just know that if I put add immutable, I get a whole bunch of stuff added, and it's all great. But if you want to tweak it, it's kind of handy to know what it gets broken down into. So you can put add immutable, and then you might come and say, oh, this map constructor, I don't want the no arg. And I don't want to include super properties and whatever it might be. And you can just come and tweak that little bit, and you can actually have a bit more control over how this magic transforms is happening. And why do I bring that up? Because that's what happens in the record space. And it's kind of handy to know this, because if you want to use records and you don't just want a one size fits all record that kind of what Java would typically give us, you can actually dive in and tweak some things. So when you see the record keyword, that actually sort of underneath the covers gets converted into record type, the annotation, and that's a meta annotation. It gets split into all these pieces, and what it means is I can come along later and add some more things. So here I've got an agenda record, and I've got a list of topics. So I'm going to talk, I've got a talk about upcoming Groovy features. I'm going to talk about sealed things and records, sealed classes and records, sealed types and records. They're agenda items. And I'm going to use a record for that. And I know that because it's a record, I'm going to have getters and no setters. So it's sort of almost like an immutable thing, but it's only shallow immutability here. So I can actually get the topics and clear them, because I happen to use a list here, and I can clear them out and put switch expressions in instead. And then if I print out the agenda again, then I'll have a different, even it's a shallow, it'll have the same topics list, but different items inside that list. So obviously I shouldn't be using lists to straight array list. This will give me an array list here. I shouldn't be using array lists if I cared about immutability, but perhaps I'm forced to use list here because of interacting with other integration with other Java classes that I might need to use. So I can come and do a bit of tweaking. So what I can come and do is, first of all, also, I might have different, this particular agenda record is in a upcoming package, and the default toString, I could go and write my own toString, but the default toString that a record's going to give me doesn't list out the package. That's probably a good thing most of the time. But if I particularly want it, maybe I've got some other I've got a hidden package, hidden agenda, that's some other agenda class that I might be using, and I want to distinguish between those. So I might want to come in and I'll intercept the toString, and I'll include names, and by default I'll get the package name, and I'm going to override the property handler, and I'm going to put in the immutable property handler. So this is the property handler that immutable uses. So I'm going to slice and dice it has an immutable property handler. I'm going to slice that immutable handler in for my agenda class here. So I've got my record agenda, slicing in these two little things. Now, when I print out my agenda, I'm going to get upcoming.agenda. So my package names come back in. I've instead of getting the record style square brackets and equals, I'm getting the round brackets and colon. I could put more things inside the toString here if I didn't want that. But now when I try to do topics.clear, it's going to throw an unsupported operation exception. This is because the immutable property handler that's part of immutable, it does not just shallow immutability, but deep immutability. So it'll do defensive copy in, defensive copy out, and so on. So in our case, when we ask for the list of topics, it actually wraps that inside an unmodifiable collection before it gives it to me. So I can have records, or I can have slight variations on records depending on what my requirements might be. So we just dive down a little bit on records. Pojo is another thing. It's actually automatic. One of the things that we automatically get for records. So by default, I'm going to get this Pojo thing. Now, what's Pojo? When you use compile static, we knew that what Groovy compiler would try to do was create a Groovy class that's more like Java. So it would not necessarily do dynamic method dispatch, but it would work all that out at compilation time. And the code that it produced looked a lot more like Java. Pojo says, go even further. Don't put Groovy object as my parent. Try wherever possible not to call into the Groovy jar at all. And when you're giving me a toString or whatever, don't call into some Groovy's toString. Try to use the same sort of code that Java would produce. So in this case here, I'm going to create a point class. You use @canonical. So that's going to give me a whole lot of boilerplate stuff, setters and getters and a whole bunch of stuff there. I'm going to use @delegate. So I'm using the delegate pattern in my point list over on the right-hand side. So these are both two Groovy classes, but I've got Pojo on both of them. And it's going to create a point and a point list class. Now I jump over to Java land, which is the code down the bottom here. I don't put the Groovy jar in my class path. And now I can start using the point and the point list and start using even the delegate type capabilities. And I'm using all of that over in Java land, happily using them, no Groovy jar in the class path at all. Now, so Pojo's a sort of way to make turn Groovy back into Lombok, if you like. It's sort of turning Groovy into a super fancy preprocessor, if you like, but fully backed by the whole AST transforms and everything. It's not a preprocessor. It's using the full Groovy compiler capabilities. Now it's incubating, only works with this sort of functionality for simple classes. If you start using dynamic code inside, if inside point list, I start doing some dynamic stuff, start using dynamic capabilities somewhere inside there, I'm going to still need the Groovy jar in my class path. Okay, so it's incubating because it's going to evolve over time, and you may get compilation errors for certain things in the future. You may get other sorts of warnings or something, but for the moment, simple classes work, and over time we'll make more and more classes work in this functionality in this way. We're going to look at Groovy contracts module, and I think we're going to be getting close to everything I wanted to cover. Groovy contracts, it supports an idiom designed by contract. So remember I talked about, these inheritance hierarchies, they're great, but we seem to get it wrong all of the time. And often what we do is we go and design an inheritance hierarchy, and then we don't follow the rules. And it's often some implicit implementation detail that we didn't think about too much. But so basically, when you're creating a parent class, it'll have certain invariants, and then everybody who extends from that class better follow those invariants. And a design by contract style forces you to make those sorts of invariants explicit. And in fact, you don't code them up at all. You declare them as invariants, and the Groovy contracts module will automatically put them in, and there's a framework there for turning them off if you need to. And there's hooks for doing that for just certain packages and so on. But that's more that we probably will do in that space. The other thing that's important in your inheritance hierarchies is if you want the behavior to be fully consistent, you've got to do what's called weaker pre and stronger post. So as you're developing new classes in your hierarchy, you've got to make sure that they work on at least the inputs that worked for any parent of you. And you better be at least as good at producing the result as any parent. If you follow those rules, you actually run into much less problems when you're doing your inheritance hierarchies. So design by contract is a way to do all that tricky inheritance stuff in a way that forces you to make things work. Now, having said that, the tricky things are often things that, so once you have state in your class, if you don't include the state in your preconditions and postconditions and variants, you're just opening yourselves up to having inheritance hierarchies that just, you're going to be evolving them in a way that it wasn't designed for. So it's tricky, but this is a framework that lets you spell those out, and it's a way to evolve those. So here we're going to say the speed of our rocket is always greater than or equal to 0. So we can't have a negative speed. We can't be hitting a black hole or something and having a time warp of some kind. When we accelerate, we can only accelerate if we've started the rocket. And what we expect to happen is that once I've invoked the accelerate method, the new speed is greater than the old speed. So we're not allowing a speed of 0 or a negative speed in this case here in our increment. And that's, we're actually going to, rather than having some sort of assertions and tests around that, check that the thing that's come in isn't 0 and have some sort of illegal argument exception or whatever, we put that in as an invariant. We're spelling it out. This is a property that I want all my subclasses to also support. And that assertion will be automatically added in. Invariants will be automatically added in all throughout the code base. And again, you can switch them off. So that's what design by contract is. And just by way of completion of that sealed example, when we added class before, when we add the toString, we could have gone and said, again, we know we could have hardened it in lots of ways, but we could have gone and said, we require that the color is not equal to null, or we could have required some set color to ensure that it didn't set it to null or whatever. And if we'd put that in place, when we created the glass subclass and tried to run it, we would have violated that precondition, and we would have known about it in a more controlled way rather than just some sort of weird error occurring. So that's an alternative way to harden. We know we've got sealed, and we know we've got other hardening options. Okay, the only other thing that's there's a bunch of GDK enhancements. There's just a couple of them listed there, plus on streams and toList on streams, and a quicker way to get the process ID on versions of the JDK that supported that. So that's just a small number of them. I'm not going to go into the, just go look at the release notes if you're interested in those. Look for the look up the GDK documentation. You'll see all of that there. Okay, that's all I wanted to cover. There is more stuff that we're looking at. Additional destructuring type stuff, module definitions in Groovy, more type checking stuff, more pattern matching stuff. Maybe some extra, there's JDK 11 has got a HTTP client. More recent JDKs have got HTTP servers. Maybe some extra hooks we'll have, maybe hooking into some of that stuff. So lots of stuff. We're keen for feedback, for people who want to tell us what they'd like to see in Groovy 5 and so on. Very, very keen for more feedback. So please come and chat to us. And you can find out how to talk to us, mailing lists and other forums. you can come and look at groovy.apache.org and find out a little bit more.
Awesome. Thank you very much, Paul. It's been a really interesting talk. I've learned a lot of new things about Groovy. So we have a few questions. One is related records. So Jorge says, record options works with pure record Java, right?
Yeah, so just for Angel, yes, I'm going to share the PDF. Records, yes, so you can use record options. It's just an annotation. And if it happens to be sitting on a class that the record type annotation AST transform is running, so one that could be using the record keyword, or it could be using the record type annotation, record options will be recognized by either of those two.
Perfect. There is another one. Paulo Di Tommaso asks if how much Jenkins is extensible to support data sources other than Java collections. I think you already answered that. I think he put that question before you explained everything, but if you can add anything.
Okay, yeah. Yeah, it's quite a bit of work to put all of the things in place to handle that. We initially were going to hope to release it at the same time as all the other parts of jQuery, but it's quite a bit of work and it might take us some time. So we'd be really wonderful if anyone's interested in that space who would like to lend us a hand. Certainly get in touch. But we'll let everyone know how we go, and if we've got any sort of alpha versions of it or whatever for people to play with, we'll certainly let people know. But it would be great if we did. It would be fantastic, but it's a fair bit of work.
Okay. Well, Mario said that he has been using Jink, querying, analyzing some CSV files, and it worked like a charm. Thanks, Mario, for sharing that.
Excellent. Thanks, Mario.
Yeah, there is another question. Rieslander asks that you mentioned there is a known performance issues with the new parser in Groovy 3. So they want to, can you expand on any plans to improve things? They want to upgrade to 3 or 4, but they are kind of cautious that maybe they will see significant hit to compile performance. Yeah,
so obviously there was a whole lot of stuff in Groovy 3, all the Lambda expressions, method references, all the Antler 4 parser is a lot more flexible. So in order to give that flexibility, it's a parser that has vastly more look ahead and vastly more power. But the flip side of that is that it's storing away more information. So we can either take up a lot more memory, or we can take up a lot more time, or a bit of both. And we've got some switches that let you play with those different options, and we'll continue to explore more switches. But we're also chatting to the Antler 4 folks, and there's people who are involved in. So we initially forked a Java grammar to start our work in the Groovy space, and the Antler 4 grammar wasn't as optimized as the Antler 2 grammar had been. And so anyway, we're talking to the Antler 4 folks. We're talking to Antler 4 has just got a new 4.10 release out. They've done a bunch of tweaks. We were actually on a slightly optimized version of Antler 4 from a different place. It doesn't have all of those tweaks yet. We're chatting to them about, can they put in some of the new tweaks that are in the 4.10 Antler, so that we can have them in our optimized one. But we're also just looking at more work that we might do to, we can put more work in on our side to try to do some better smart guessing at when we need to do more memory and when we need to do more time, and when we, using some heuristics or something, we might be able to do a bunch of stuff that lets the parser be faster for the majority of people, but only slow down for people who are doing the really tricky stuff. So it's something that's, we don't have a huge team. So anyone who's interested in that stuff, we're very keen to chat to you. but it's something that's on our to-do list. And now that Groovy 4's out, it's starting to percolate back up towards the top of the to-do list. It was sort of just being pushed off while we got Groovy 4 out, but it's now something that we're looking at. And going from 3 to 4 there's some minor changes yet again to add a few more, sealed and record keywords and so on, but not a huge degradation, but it's again something that we'll look at and try to make better. But yeah, ongoing work. Please come along and help us if you've got time and inclination in that space.
Sure. Yeah, another question. Are you aware of a decent formatter prettifier for Groovy? Jamie started working on one for Groovy 2.5, but ran into some issues. So I wonder if this would be easier with Untitled 4.
Yep, a lot of us are sort of spoiled by our IDEs, and IDEs have that sort of formatting and prettifying functionality built into them. And some of the online IDEs are just starting to support Groovy as well. But certainly there are standalone tools that it would be nice if they had support as well. And there has been various efforts over the years to make those work with various versions of Groovy. But yeah, I don't think there's any that are currently fully supportive of Groovy 3 and Groovy 4. So it's certainly something we probably need to go back and have a look at, see where we're at, see whether we can piggyback on any of some of the online IDE activities. Maybe there's an extra hook that some of those might even give us that might give us an easy out. But yeah, certainly a lot of us fall back to using our IDEs for that functionality, but it'd be good not to have to.
Excellent. So we don't have any more questions. So if last seconds to ask Paul anything, I want to thank you again, Paul, for being here. As you probably know, Paul is in Australia, so it's like 9:30 p.m. for him. That's why we did our meetup here at noon instead of our usual during the afternoon. So I think that's it. If you want to join the raffle, please don't leave. And again, thank you very much, Paul, for joining us to explain everything, all the new features in Groovy 4. So yeah, thank you.
No worries. Thanks very much for having me. I'll make sure that the slides and code's all up as well, and I'll send a tweet around for that.
Perfect. We will publish the video in a couple of days, and I will share also the link to the slides. Okay. See you next time, folks. Bye bye.
Thank you.